we're going to balance some chemical equations. To do this, we need to understand molecules. So first, let me introduce a couple ideas. This is what a water molecule looks like. 2 hydrogen and 1 oxygen. Kind of looks like Mickey Mouse. We would write it like this, H2O, because there's 2 hydrogen and 1 oxygen. Now you really could say H2O1, but the 1 is implied, so we never do write the 1, even though it truly is there. Now what if I have a whole bunch of water molecules? I don't want to draw out all these water molecules. I could do this. If I have 4 water molecules, I could write it out like this. H2O, and I have some more H2O, and I have some more water, and let's have some more water. That's a lot of writing. But that would be 4 molecules of water. I would have how many hydrogens total? 2, 4, 6, 8. How many oxygens? 1, 2, 3, 4. But this is a bothersome long way to write things. So what we do instead is, instead of writing it out 4 times, we just put a big old 4 in front of H2O. So this really is the same thing. And if I really do want to count up how many hydrogens or oxygens I have, I can just multiply this 4 times that 2 and say 4 times 2 is 8 hydrogens. And I know there's a 1 there really. How many oxygens would be here? 4 times 1 is 4. If you really must see, you can write it out this way. But this is a shorter way of writing it. This is called a coefficient. And it basically says, I have this many of this molecule. These little numbers are called subscripts. And it basically says, I have this many H's, 2 H's in this molecule. And I have 1 oxygen in this molecule. And then this says I have 4 of those molecules. Okay? Now you can't write this. You cannot write, since there's 8 hydrogens, H8O4. Because there's 8 hydrogens, this would not taste like water. And it would not boil like water. It wouldn't do anything like water because it wouldn't be water. So when we do these balancing chemical equations, one of the rules is that we can never ever change the subscripts. So this is out. This number you can change, and it's still water. It's still water. That's a lot of water. And that's just 1 water molecule. If there's no number in front, it's assumed to be a 1. Now, let's balance a chemical equation. This is the equation I want to balance. Now, this equation, just for some backstory, would be what is in a hydrogen-powered car. You would have hydrogen gas, and you would burn it with oxygen, and then you would end up with H2O as your waste product. But this equation is not balanced. What does that mean, it's not balanced? Well, let's check some things out. I'm going to write a big T underneath the equation. And I'm going to draw my down line underneath the arrow. This T, pretend it stands for the word tally. Because we're going to tally up how many hydrogens are on this side and how many oxygens are on this side. This side over here these are called the reactants. And this side over here are called the products. These are what react together, and this is what is produced. Now let's count up. How many H's are on this side, the reactant side? There are 2 H's. How many O's are on the reactant side? There are 2 O's. Let's look at the product side. How many H's are on the product side? There's 2. How many O's, oxygens, are on the product side? Well, there's an implied 1 there, so there's only 1. This is a problem. This is unbalanced because in nature, matter is not going to be destroyed. All of the items on this side are simply rearranged on this side. every piece still needs to be represented on both sides. So our goal is to add coefficients to the fronts of all of these formulas until the numbers down here match. So let's do that. Let's see here. And it's like solving a puzzle. And it's kind of fun, and sometimes it's kind of frustrating. But here's how it goes. I look over here and I say, now look, I don't have enough oxygens over here. I have to raise this one up to be a 2. I can only change the numbers in front, the coefficients. So I'm going to put here, there's an implied 1 there right now, but let's put a 2 there. And now if I put a 2 there, that changes everything. Now I have how many oxygens? Well, this number applies to the whole molecule. So now I have 2 times 1 oxygen. Now I have 2. Yay, it matches. That's awesome. However, I did mess something up. When I put that 2 there, it also made there be more hydrogen. So how many hydrogens do I have now? Well, 2 times 2 is 4. Well, it was nice while it lasted, but now it doesn't match anymore. So I have to come back to this side. Now I need to add something here to fix the new problem I just made. I need to have more hydrogens. I need to up this number. So there's an implied 1 here. Let's now make it a 2 instead. 2 times 2 is 4. Now look, these match. And these match. So I'm done. It's balanced. My answer is really this up here. Down here is just my work to tally it up. But this is the true answer. In my hydrogen-powered car, I would need 2 molecules of hydrogen for every 1 molecule of oxygen. And every time I had 2 of these and 1 of these, I would produce 2 water molecules. I've made my formula, my equation, match what is actually occurring in nature. I need this in a 2-to-1 ratio to make those water molecules. This is the balanced equation.